Hey everyone! Are your sprints constantly derailed by spaghetti code and CSS conflicts? Technical debt is quietly draining your team's energy. Stick around because today we're exploring how to crush technical debt and stop reinventing the wheel using a centralized design system. Let's go!
So let's dive right into this question. Because when you're just starting out, you are inevitably going to feel the friction of bloated code holding back your brilliant new features. You get assigned a ticket to build something cool, right? But then you end up spending 80% of your time just trying to untangle the absolute mess left behind by previous sprints. You know the exact feeling. Spending 4 hours trying to figure out why an undocumented exclamation point important tag is breaking your whole layout. Or fighting those endless z-index wars just to get a simple modal to sit correctly on top of a nav bar. It's frustrating, it completely drains your energy, and it slows down the entire product pipeline. We've got to fix that.
All right, here is our game plan for today's explainer. We'll start with the trap of technical debt, explore building the design system, master the developer handoff, dive into components and code reusability, tackle the human side of handoffs, and finally, scale without the bloat.
Let's jump right into Section 1, the trap of technical debt, and how we escape this nasty cycle of bad code. We've all been there, taking a quick shortcut just to hit a tight deadline. But let's look at what that actually costs us.
Basically, the crucial point here is that this debt accrues interest. Just like real financial debt, when you take a shortcut today, you pay heavily for it tomorrow. It creates this vicious cycle of higher maintenance costs and slower development. When you rush a feature without thinking about the overarching architecture, you're essentially borrowing capacity from your future sprints. And eventually, that borrowed time catches up with you. Suddenly, your team's entire sprint capacity is going toward putting out fires and fixing bugs, rather than shipping actual value to the user. Trust me on this one, your future self is not going to be happy about it.
Right now, you might be stuck in the painful old way of working. You know, deadline-driven shortcuts, dealing with a constantly bloated code base, working in complete silos, and literally just tossing messy design files over a brick wall to the engineering team. But there is a totally new way. This new approach relies heavily on structural consistency. It's a unified workflow where designers and developers actually speak a shared language, which unlocks incredibly fast, predictable iterations.
Which brings us to Section 2, building the design system. Think of this as your ultimate weapon. To defeat technical debt during production, you have to shift from working harder to working smarter. When you're building out a feature, I want you to rely on a structured breakdown like this as your single source of truth. A robust system has 4 core pillars. First up, design tokens. Think of these as your foundational variables. If marketing suddenly decides they want to change the primary brand blue across the whole app, you definitely do not want to be doing a manual find and replace on 50 different CSS files. With tokens, you change one exact hex code in your variables file, and it cascades everywhere perfectly. Next, UI components, your reusable building blocks like buttons and input fields. Then, patterns, which define exactly how these blocks interact to form user flows. And finally, guidelines, to ensure everything you build meets strict accessibility standards and best practices. It's like a giant puzzle, but all the pieces are structurally guaranteed to fit.
Now, if you're wondering, is that upfront architectural effort really worth it? Check this out, 68%. When Airbnb implemented their internal design language system, it reduced design inconsistencies by a massive 68%. Just imagine cutting out almost 70% of the visual bugs, the weird margin issues, and layout misalignments in your app, simply by sticking to a centralized set of rules.
Let's move on to Section 3, mastering the developer handoff, the bridge between design and code. Because let's be real, a beautifully crafted design system is completely useless if the handoff to engineering is a total disaster.
Let's stick with that same Airbnb system for a second. It didn't just make things look pretty, it actually cut developer handoff time by 34%. This proves that structured systems actively and directly speed up our engineering workflow. You get a third of your time back. You spend way less time measuring pixel distances with an inspector tool trying to decode what a designer meant, and far more time actually building out the core business logic. As a dev, your goal here is to rigorously follow these specific steps to bridge the gap between static designs and the functional apps you're building. We need interactive prototypes that actually show us state changes on hover or click, not just flat JPEG images. We need crystal clear documentation listing dependencies and dimensions. And crucially, we need dedicated version control for design files. We can't be pulling our hair out trying to build from a file named final_v3_draft.figma. We have all been there, and honestly, it's a nightmare.
Speaking of version control, 60%. If your team treats design files like code and uses organized version control platforms, you can drop file conflicts and mismatches by an incredible 60%. When design tokens are versioned exactly like your repo branches, everyone stays in sync automatically. That is a massive drop in the daily friction that normally kills our sprint velocity. Moving right along to Section 4, Components and Code Reusability. This is where we actively crush debt during production by stopping the endless reinvention of the wheel. No more coding a brand new drop-down menu every single time PM asks for one. Check out this number, 70% faster. By building heavily with a shared component library, using frameworks like React, Vue, or Angular, engineering teams report dev cycles up to 70% faster. You are no longer coding a warning button from scratch. You just import the button component, pass in the warning variant and large size props, and boom, you're done. No custom CSS classes everywhere. No worrying about prop drilling or weird cascading side effects. You just leverage the system.
This modular architecture is essentially your roadmap to massive dual benefits across the board. For design, it means standardized UI elements. But look at the development impact here. Reusable code patterns, drastically faster implementation, and an architecture that practically eliminates maintenance overhead. When a critical bug gets fixed in the core button component, it is instantly, automatically fixed everywhere that button lives across the whole application. It's magic.
Okay, Section 5, the human side of handoffs, or translating intent into code. Keep in mind, technical debt isn't just about outdated JavaScript frameworks. It's almost always the direct result of bad communication between human beings. This one hurts. A staggering 62% of developers spend way too much time redoing designs simply because of communication breakdowns. That means more than half of us are doing the exact same work twice. Not because the code was technically wrong, but because we totally misunderstood the original intent. You spend hours meticulously coding a complex desktop view, only to toss half that work out because you misunderstood the responsive behavior for mobile.
I want you to consider this thought from the Zeppelin blog as your absolute golden rule. Handoff is not just passing over a static file and walking away. You must deeply understand the why behind a design decision before you write a single line of code. If you don't know the context of the user's journey, your code might compile perfectly, but it's going to be practically useless to the end user.
So to fix this communication gap, adopt these targeted practices. Sit down with your designers, understand their rationales. Most importantly, rigorously discuss edge cases before you start typing. What happens to this beautifully designed user profile card if the user's name is like 50 characters long? What happens if the backend API completely fails and returns a 500 error? What does the skeleton loader look like while we wait for a slow query? Talk it out, run regular syncs, and watch how fast that friction disappears.
And finally, Section 6, Scaling without the bloat and future-proofing your work. Let's look at the ultimate payoff, because our goal is scaling efficiently without letting the codebase rot as it grows.
Look, a design system is definitely not a set-it-and-forget-it kind of project. It is a living, breathing ecosystem. You gotta start small, sure, but you desperately need continuous integration, automated style guides, and regular code audits to keep things healthy. An audit basically means checking the codebase for rogue, hard-coded values that devs slipped in to bypass the system. Actually, think of it this way. If you don't actively maintain the design system itself literally just becomes another form of technical debt.
But when you do maintain it, when you ruthlessly eliminate redundancy and focus on reusable systems, these are the massive operational wins you deliver to the business. Drastically lower maintenance costs, incredibly fast time to market, and consistently high quality. This mindset shift right here, this is exactly how you level up from being just a junior coder churning through tickets to becoming a highly impactful senior software engineer. You stop writing isolated lines of code and you start engineering massive, scalable solutions.
So I'm going to leave you with this challenge for your very next sprint. When you look at your next ticket and read those requirements, ask yourself, will your next line of code add to the technical debt, or will it build upon and strengthen the system? Think carefully about your answer. All right, let's go build something sustainable.